In this experiment, we'll be trying to identify a series of aqueous solutions using chemical methods. We are going to apply our lab safety knowledge to continue to work safely in the lab. We will also work on developing our observation and note-taking skills through qualitative observations to identify the 10 aqueous solutions based on the chemical reactions that occur and other properties of the solution. We will apply the solubility rules to write balanced chemical reactions and then practice writing net ionic equations. When we study chemical reactions, chemists, at the most simplest level, classify reactions into 5 types: combination, decomposition, single displacement, double replacement, and combustion. We've already seen a couple of these types in actions when we performed the composition of limestone experiment and synthesized aspirin. In this lab, we're going to explore some of the driving forces behind chemical reactions, particularly the double displacement reactions, and one of the ways that we know that a chemical reaction is occurring. Chemical reactions are driven by the formation of stable, lower energy products. With aqueous solutions, there's typically 3 things that are going to happen. We're either going to see formation of a precipitate, which is a solid coming out of the solution, a neutralization, which is what you see when you have an acid reacting with a base, or a redox type reaction where you have transfer of electrons between different substances. With this lab, we are focusing on precipitation reactions, or those that have a solid form and come out of solution once the reaction occurs. We know a precipitation reaction occurs because we can see the solid at the bottom of our aqueous solution as it forms as the chemical reaction occurs. So the question then is, how do we know what that substance is that's forming as a solid at the end of the chemical reaction? And what we've got to do is apply the solubility rules, which is based upon what we already know about some chemical reactions. And we're going to look at those solubility rules and determine what is and is not solid in an aqueous solution. When we talk about precipitation reactions, we talk about the molecular reaction that's occurring, the substances that are involved in the reaction. So the molecular reaction is one that simply shows the substances and bases involved in a chemical reaction and their stoichiometry. When we talk about balanced chemical reactions, we're referring to the molecular equation oftentimes. For example, if we use lead-2 nitrate and react it with sodium chloride to form lead-2 chloride and sodium nitrate, I've shown the balanced reaction there on the screen. As we move through chemical reactions and precipitation reactions, and we go from talking about the substances in general when they break apart in solution and what ions are present in solution, we talk about the ionic reaction. The ionic reaction, it shows all the ions that are present in the solution. If you think about taking the starting materials, the lead-2 nitrate and the sodium chloride, and mixing them in a beaker, what ions become present? We know that the lead-2 nitrate will break apart and you'll form lead plus 2 plus the nitrate ion, NO3. These are, of course, aqueous in solution. The sodium chloride, we know, is also going to break apart into its various ions, so we'll just go ahead and list those out. And then what else is going to be aqueous in solution? We can see from our balanced chemical reaction, you also have, on the product side, some sodium ions that'll form. We still have nitrate ions that'll form. But we also have something that's no longer in solution. We have this solid. That solid, it's not going to break apart. Oops, that should be a solid. So it's going to stay together as it forms a solid. These, of course, it's still going to be balanced, so we need to make sure to remember those coefficients. So 2 sodium ions, 2 chloride ions, 2 sodiums, 2 nitrates, so this is still going to be, of course, balanced. When we talk about a net ionic equation, we're then only going to show, and we're only interested in the ions that are involved in forming our precipitate, or that solid at the end. So sometimes it's helpful if you start off by identifying what's the solid that forms. So I'm just going to write that down first, and then look back to my reactant side and see what ions started from. So I'm going to just go ahead and write those down. These are both aqueous. And again, or you can also think about it as looking at the net ionic reaction and determining what ions are on both sides of the equation and kind of canceling them out. So if we look at this ionic reaction, we see that we have the nitrate ions on both sides, 2 of them. We got 2 sodium ions, and they can kind of cancel out, leaving us with the lead +2 and the 2 chloride ions. So let's look at another example. What is the net ionic equation for the reaction of sodium carbonate with magnesium chloride? So the first thing we're going to want to do is write out that balanced chemical reaction. Na2CO3 aqueous plus MgCl2. Remembering we need to put the phases. And it's going to form some kind of products. This is a point in which we often are going to look back at our solubility rules, which can be found in the appendix to our lab manual, and compare them with what kind of things we think we're going to form. First, I'm going to start off just by writing out our products using a displacement reaction. So I know that we're going to kind of switch ionic partners here. So I know I'm going to form sodium chloride and magnesium carbonate. Okay. We're also going to think a little bit about charges, do our charges balance. We know the magnesium is typically a +2 and the carbonate a -2, so that's going to balance. If we look at our solubility rules, we know that sodium chloride, it's going to be soluble in water, because again, that's table salt. So then, again, going back and look at those solubility rules, we can determine that the magnesium carbonate is going to form a solid. All right, so we're going to want to look really fast and see if our reaction is balanced. We got 2 sodiums on the left side, so we're going to need 2 sodiums on the right. We've got 2 chloride ions on the left, 2 chloride atoms on the right, magnesium 1 and 1, and the carbonates 1 carbonate group and 1 carbonate group. So our reaction is now balanced. So then we need to determine the ionic equation. Ionic reaction, all the ions that are present in solution. So we're just going to start breaking stuff apart that's aqueous. So we know sodium's a +1, and we've got 2 of them, plus the carbonate, 3, 2 minus, plus magnesium, that's a 2+ charge. Aqueous solution, we got 2 chloride ions in solution as well, and that's going to form our sodium chloride. So our sodium will break apart and form an ion. We'll have 2 chloride ions. Wow, did I write solid up there? Wow, that's bad. This is aqueous. Wow. And then we're going to have magnesium carbonate forming as a solid. So then now it's just a matter of doing some cancellation and looking to see what solid is formed. Like I said, I'm going to just take a quick shortcut and say I know that the magnesium carbonate forms as a solid, so that's going to go on the reactant side. Check really quick. Sodiums are on both sides. That can cancel out. The chlorides on both sides. That'll cancel out, leaving us with magnesium 2+. Plus carbonate, CO3 2 minus, and solution, and then they'll react together, giving us the magnesium carbonate solid. So in lab this week, we're going to be systematically testing 10 different solutions and seeing how, as they combine together, what happens and if we have a precipitate form. The biggest thing that you need to do is make sure you're writing down plenty of observations in your lab notebook and keeping both the solutions that you've prepared and the data that you're collecting organized. And it's also important that you review that data when you're done to make sure if you need to do a test again, because once you leave the lab, you can't go back and repeat a test. And you've got to have all of that data so you can complete the assignment up on Chem 21 based on the data that you collected. The easiest way to organize your data is to kind of make a matrix. We know from the scientific method that you want to test one variable at a time, so you're best off starting off by testing one reaction at a time, one substance at a time. So you want to approach this, like I said, from building a matrix, and you'll work your way down your column. The nice thing about the matrix also is that you can use it to fill in what you see. So for instance, if you see a reaction occurring between solution A and solution B, you can write in that you saw a precipitate and its color. Not necessarily this is what you're going to see, but it's something that, remember, One of the easiest way to get wrong experimental results is to start off with dirty glassware. So the first thing you want to do when you walk into the lab is wash those well plates before you get started. You're going to want to make sure you use soap and water and rinse them well. Because of the size of the 96 well plate wells, it's probably a good idea to go ahead and use some Q-tips to get down in those wells and clean them out really well. You should not assume that anybody that used the well plates before you did a good job cleaning them out. You should also keep in mind that you're going to be doing a number of chemical reactions throughout this experiment. You don't want to do them all at once because more than one may give off an odor. If you've got multiple odors being given off from a single reaction at one time, it's hard to tell which one of the wells in your well plate that odor is coming from. So it's important, again, that you mix the solutions together one at a time. If you suspect a reaction releases an odor, you may want to repeat that reaction in a test tube or in the larger well plates using a little bit more solution. And remember, proper technique when you're smelling a solution is to waft the odor towards your nose and not to put your nose right into where you think the smell is coming from. This experiment is really going to emphasize the solubility rules. So you want to make sure that you look up the solubility rules in the appendix to the lab manual and memorize them because you're going to need them when you go and take your exams. In some cases, some substances don't react following the solubility rules, so those are going to be indicated in the lab manual in the experiments reading. Make sure anytime you write down a substance or you're writing a balanced chemical reaction that you also include the phases when writing those reactions because it's important that we know what the precipitate is that forms. So which one of the substance forming as a product is the solid. By the end of the lab experiment, you should have enough evidence gathered to be able to identify what all of the unknown solutions are. You're going to have to work through this systematically like a puzzle, starting from the one thing you know you can identify for sure, and then kind of using what you know about solubility to figure out what other substances are. When you go to do your assignment, you're going to need to give us at least 2 different pieces of supporting evidence to support your identification of the unknown solutions. These are going to be, of course, separate of the net ionic equation that you're going to have to write as well. The evidence that you provide needs to be based on your results that you collected. This could be, that you're going to be applying the solubility rules. You could be using hints from the lab manual or the results of your tests that you ran in the lab. And all of this information needs to be in your lab notebook. So we're going to be looking for a number of things, but one thing to keep in mind is what not to do. You've got to remember when you write down and you tell us that, say, sodium bromide reacts with silver nitrate to give a yellow precipitate, that saying that in words is just the same as saying it using a net ionic equation or using the symbols, the balanced chemical reaction. So don't do that. They need to be completely different. We want you to be able to identify substances using 2 different reactions or 2 different pieces of information. A lot of the times you're going to find you probably have more information than just 2 things that make a particular substance react in a unique way. So you would probably want to say something to the effect of the sodium bromide does not react with copper sulfate to form a precipitate. That's very different from saying that the bromide ion reacts with silver ion to form silver bromide. Remember, you need to explicitly state what happened with your solution or what you observed with a particular solution. Simply stating the number of reactions that occurred without details about what happened is not going to be accepted. Remember, we're going to need to collect up any waste that's produced at the end of the lab. Probably the easiest thing to do is keep a beaker at your station to pour all of your waste in when you're done, and then go over to the waste container in the hood and pour all your waste into the waste container. Any of the semi-micro glass test tubes that you use need to be emptied, and then they can go into the glass waste container up at the front of the room. Remember, when you go up to the hood to pour your waste in the waste container, to check to see if the lid of the waste container is opened or closed. If it's closed, please make sure you lift it up before you pour any waste in.